Hey everyone, this is Nick Diobertis teaching you financial modeling. Today we're going to be talking about how to calculate free cash flows in Python using Pandas and finstmt. This is part of our lecture series on free cash flow estimation and forecasting as part of a larger goal of building out the discounted cash flow valuation of a stock. So we already gave an introduction to the free cash flow side of the model and how to calculate free cash flows historically in prior videos. So take a look at those if you haven't already. And now we're going to actually just jump right into the calculation in Python. So let's go over to the Jupyter Notebook. So at first we'll look at just using Pandas, and then we'll look at an additional tool that I developed called finstmt that makes some of this process quite a bit easier. But first focusing just on Pandas, so we have some financial statements in an external Excel file, and we want to get them into Python. So the first thing I'm going to do is import pandas and just set the name of that file, which has the financial statements. And I'm going to read that in with Pandas's read Excel method. And then we can just do .head on the resulting data frame to check out what we got. Now we can immediately see this is maybe not 100% what we expected to get. It looks a little bit messy. We have this unnamed thing. We have these nans going on. Sometimes it's nans, sometimes it's dashes. So some cleanup is needed here in order to work with this. One other thing is that these statement line items, if we have them in the index, we'll be able to look up the various line items, but it's a little bit more difficult to do that when they're just in a column. So we can add this argument to the read Excel method, and index column equals 0. And when we do that, it's saying take the first column here and set that as the index. And so that solves our unnamed issue because now that's the index. It doesn't need a name. And it solves this issue of these things should probably be in the index. Now they are. So then next we have to deal with this nan versus dash issue. Nan is the representation for missing in Pandas, and dash were just some strings in the Excel file that got loaded in, where that's how the Excel file is representing them as missing. But here they're coming in as the string dash. So ultimately we want to clear out these empty rows, and we want to make sure that when something is missing, that we're actually getting it as missing and not as a string. So what we can do is we want to replace this dash with the missing representation, NaN. And you import, once you import NumPy, then it's numpy.nan. That's the missing representation. So we're just replacing everywhere in the data frame where there's the string dash with a missing. And then we can see that what was a dash before now is this same NaN, not a number, missing value. So now that we have the missing values appropriately where they should be, now we can go ahead and drop the missing values. But we don't want to accidentally drop this. This is important to keep this other revenue, even though the others are not there. And so we will pass to the drop NA method this how argument of how equals all, saying that we only want to drop the row if every value in the row is missing. So when we do that, then we see that these totally blank rows that were there before are now gone, but we're still left with the row that had some missings in it, but at least one valid value. So now this is looking quite a bit better than what we started with. So we can go ahead and wrap these steps up into a function load and clean statement data frame. You give it the path of the statements and the name of the sheet, and it does these 3 steps that we mentioned. So then here I'm just starting again from scratch by using that function. And we're loading in the income statement, and now we can see it just looks like this already. And it was good to build out a function for this because we were going to have to do all the same things with the balance sheet. So now that just becomes a one-liner. We can do the same thing with the balance sheet, and that comes in nice and clean as well. So that's the kind of initial loading process that you do with Pandas, and you'll need to do that regardless of whether you choose to do the actual free cash flow calculation with Pandas or with finstatement. But let's look at how we can do all this with just Pandas first. So as a reminder, for what we're doing, we're calculating these 3 adjustments to net income, non-cash expenses, increase in working capital, and capital expenditures, all explained in the prior videos. And then we're going to calculate the free cash flow from the net income and these items. So we are going to need to work with these statement items. So let's look at everything that we've got. We can do .index to see everything that's in that index. And you can see all the different items that we have here. And then in order to look up a given item, we can use .loc and then pass it the string of the index value in order to get that entire row of the data frame. So we can get this asset write-down expense by doing .loc with asset write-down, and we can see it gets us each year of the expense as a Pandas series. So one other thing we have to consider is we've said in our calculation that we're going to add this, but it's coming as a negative number here. So we need to think about basically the costs on the income statement. Are they being represented as negative or positive numbers? Different financial statements will show it differently. Because you can say, well, it's a positive cost, so it subtracts, or you can say, well, the cost is subtracting, and so it's negative. So you'll need to pay attention to that and handle that as you work with the line items. So we want this to be a positive cost, and so we're going to take the absolute value with the built-in ADS function. So we're trying to calculate this non-cash expenses. So we'll also need the depreciation, so we can grab that. And since we can do math directly with series, we can just add these 2 things together. And now we can see that we have these values added together appropriately. But we'll notice that something strange here happened with the first 2 years. Even though we had depreciation numbers for that year, we're now getting missing. And that's because the numbers were missing in this other series of the impairment or asset write-down. So whenever you do math with a missing number, it's going to cause the whole calculation to become missing. But really in this case, it wasn't missing. It should have been 0 for these. There just was no expense, and so it ended up as missing, but really it's 0. So what we can do is fill in all those missing values in the data frames with a 0. So that's what this fill in is doing. We're going to put a 0 in for everywhere that had a missing number. And then when we look again at this impairment charge, we now see zeros coming there, and that allows the calculation to go through as expected. So then we can go ahead and do the full calculation of these 4 different line items. And then we get our non-cash expenses here as a series. Next, we go to calculating the change in working capital. So we need to pull the appropriate items. So let's look at our index again. We're going to need to use accounts receivable, inventory, and accounts payable. So we just put those things together and we get these connected together. But now this is the current net working capital. We need to calculate the change in net working capital. So there is a way to do this change kind of concept in Pandas. If we use the dot shift method, that allows us to move the series values up or down by a certain number. So here, shift 1 is going to move all the values forward by 1 period. So that when we look at the 2015 value, what we have in the shifted is actually the 2014 value. So that's what we want to calculate the change. We want to do the original minus the shifted by 1 period. And then, of course, we can't get the first period because we have no prior period. But then looking at the second, we're getting 1481, which appears to be the change between 15 and, between 14 and 15. So that looks like it's working appropriately. Then we need to calculate capital expenditures. And you'll notice back when we look at this index, that net property, plant, and equipment came with a space on the beginning. So unfortunately, we do need to include that space unless we go and change the name of the column. When we do it like that, we're able to look it up. But if we did it without the space, we would get an error. So you do need to be careful about your column names, and they're not always going to be loaded in perfectly cleanly when you just pull in an Excel sheet. So you may want to just rename the items, or you can just work with them as is with the additional spacing or whatever else is coming in. Anyway, we get our net PPE here with .loc, and then we want to get the change in that, similarly to what we did for the net working capital. And then to the change, we add the current depreciation and amortization. So here now we have the capital expenditures. So then we just put all that together into the free cash flows, take the net income, add the non-cash expenses, subtract the change in net working capital, and subtract the capex. And there we are left with the free cash flows. And of course, we can't get them for the first year because we had no prior year for the changed items. So then we can look at perhaps an easier way to go about this using the fin statement package. So I actually created this package because I felt like this process that we just went through was a little bit arduous, or something that should be pretty simple and that lots of people need to do. And there were a number of things about this that make it difficult to repeat, and make the code just very tied to these specific financial statements rather than working for any given statements that you would want to work with. You're going to have different names in the financial statements from different data providers, so you'd have to go back and switch out these names. And we're getting extra spaces and stuff in there that would also be affected by where you're getting the statements from. And then we had this negative versus positive for cost issue. Sometimes you might need to be taking the absolute value, other times not. And it's, the .loc thing is a little bit annoying in order to look up items. Getting the change is also a little bit annoying. It's not too bad, but a little bit verbose. And we also need to think about, well, is this item on the income statement? Is it on the balance sheet? And then find it and work with it. we had to remember about this cleanup with the zeros, filling in the zeros. Um, and of course, we had to go through all these manual steps ourselves to calculate the free cash flow. People calculate free cash flow all the time. Shouldn't there just be a simple way to do that? So I created this fin statement package to solve all these kinds of issues. And the reason I think something like this was not out there already is most of the um, Python finance code which is out there just exists within uh, large banks for the most part. And so it's closed source. They're not sharing it with anybody. But I wanted to make this analysis easier for everyone. And so I have open sourced all this code. So you're going to need to install the fin statement package. It does not come in Anaconda because I only recently created it. So you're going to need to do the install. And we've covered installing packages in prior videos. And since I already have it installed, I can just go ahead and import it. And for now, the conventional import is to import the income statement, balance sheet, and financial statements from FinStatement. As of now, it supports the income statement and balance sheet. So we're going to use that same method we had from before because it is expecting to receive kind of this cleaned up structure. You pass it data frames in order to create the statements, and it expects that your line items are in the index and that you have dates as the columns, which is the structure that we set up in the beginning of the video. So then, we have those data frames which are ready to go. And we can load in the financial statement, income statement class from that income data frame. So we run that and we do see some output here, which is just, it mentions the items which it saw in the data frame, which it was not able to assign to a statement item. So most of this stuff is just are things that you don't really need, and that's why they're showing up here. So what does this look like when we examine the data? So you'll notice a few things about this versus the data frame that we were just working with. One is that it kind of just has the core items displayed here, not all these extra things. The dates have been reformatted. And you'll notice that we have the dollar formatting with commas automatically everywhere, and that we have dashes now to represent the 0 or missing values. Um, so, and then we can use tab completion on that income statement data to be able to pull whatever item that we want out of the income statement. So you can see all these different options here. And then let's just think about getting the revenue. All we do is dot revenue, and we get the revenue series. So just like what we had to do dot loc for and pass it the specific name, however it's coming in the original data, now we just do dot revenue regardless of how the original name was in the original data. And then we can pull periods out of the financial statements. So here I'm just pulling the 2014 period, and we just get that. You can also pull out multiple periods by giving a list of the periods that you want. And you'll notice also that these don't exactly match up in terms of date format, right? This is with dashes with year first. This is slashes with year last. But the package is smart enough to understand that you're talking about the same date and grab the correct periods. So we can go ahead and create the balance sheet as well. So we see a similar message coming up there about things it wasn't able to extract because a lot of them weren't actually even balance sheet items. and we can look at the data there as well. So seeing similar things in terms of the structure compared to the income statement. So there's one even more high level way to work with the package, and that is you can create a financial statements class out of both the income statement and balance sheet. So we create that statements class, and then what that allows us to do is work with the whole statements at once. So if we just look at statements, we'll see we get this header of the income statement. It shows the income statement, and then we'll get this header of the balance sheet, and it shows the balance sheet, so we can see everything. And then we have this same thing where we can do the tab completion, but now it works across both the income statement and the balance sheet. So we have all those possible items there. We can get the cash from the balance sheet, we can get the cost of goods sold from the income statement, and we don't have to think about where that item actually comes from. And we can do the same kind of date access as we can with the individual statements. And this can be useful in order to pull certain items for different time ranges. Here I'm just getting the total equity for 14 and 15. So then getting into calculating the free cash flows, well, there is a .FCF, and that gets you the free cash flows. So you're done. We didn't have to calculate all those separate items and put them together, just .FCF, and you have the free cash flows. So nice and straightforward. But just to show some of the other convenient methods that have been added to the library to work with statement data, let's look at how we would go and calculate those free cash flows manually using finstatement. So we take the net PPE, and we have this lag method, which is able to do the same thing as shift in Pandas. So we're going to lag it by 1 period, and then we also have this change method. So the change is already doing just the original minus the lagged by 1 period, but it's just a more convenient way to get at the change because the change is often what we're concerned about getting. So in order to calculate the free cash flows, all these parts are calculated for you as well. Like the networking capital is already there, the capex is already there, the non-cash expenses is already there, and so you can just directly go and add up those items and use the change on the networking capital. So definitely simplifies this process quite a bit. And then the same exact code is going to work no matter which financial statements you're working with. And some other things I want to mention about using the package. So I've gotten this working with StockRow and Capital IQ financial statements. I think it will work for a lot of others as well. But if you load in your financial statements and something goes wrong, just send them to me and I'll make sure that they get incorporated into the package as well. And there is basically a configuration system within finstatement, which allows you to extend it to be able to work with any custom statements that you want to work with. But I'm still working on filling out the documentation on all that. So if you are interested in customizing how this works at all, just reach out and I'll give you some guidance there. So, and also if you see any other issues with the library or things are not working as you would expect, also just reach out and I would be happy to look into whatever issues that you have. So that's an overview on how to calculate historical free cash flows in Python using both Pandas and finstatement. So thanks for listening and see you next time.